A very good evening to one all present over here. Myself, Dr. Sheena. So today we'll be having a discussion on the most commonly and most frequently asked NEET MDS question over the last 2017-2025 year range. And I have included like a lot of questions from both the Kerala entrance as well as the All India entrance examination. And today we have been concised our discussion on some of the topics like the physical property of the material, the impression materials, and the resin restorative materials, etc. So let us go to the topic, most important topic, and I have given some discussion portion regarding to each question also. The first question is the shape of indenter in a noob hardness test. So we know that for a hardness test is a physical test property. So there are various tests that has actually been done for the hardness. So before doing this question, I'll just brief out the important points that you have to keep in mind while you answer this question. So first is like we know the hardness is like our four type: Brinell test, Rockwell test, Vickers test, and Knoop test. To keep in mind, a lot of questions has been asked from these areas. That is why I've given a very short explanation and a very important point to remember from this. And each description that I've given in the subsequent slides is a single question. I haven't again added the question and answer, but it is actually a single question that has been added. First is Brinell test. So as you can see in the image, the Brinell test actually have a very small stainless ball that is having a diameter. That is another question. What is the diameter of the small stainless ball? It is 1.6 mm diameter. And you can see the red marked area. That is another question. How is the Brinell test been related to? They are actually related to the tensile strength as well as the proportional limit. And to keep in mind, Brinell test is actually used mainly for the hardness of metal and metallic materials. Okay, this is very three important point that you have to keep in mind while you discuss Brinell's test. Next, you can see what I've added in the next line. Dental gold alloy. Also, we actually use the Brinell's test, and which is the oldest test. Brinell's test is actually one of the oldest tests that is actually used in hardness determination. So see, this is one of the question asked. Brinell hardness test directly proportional to which of the following? Modulus of elasticity, modulus of resilience, ductility, tensile strength. We've already discussed in the last slide. It actually depends upon two important things. That is the proportional limit and the tensile strength. So the answer for this question is tensile strength. Rockwell test actually have in the previous slide they had a round structure. Here they have a conical diamond point and which actually determine the depth of penetration by measuring the dial gauge. That is what it has been used for. And this is not at all used for brittle material. Because test is having another shape, not conical, it is having a square shaped pyramid indenter, and they are actually used obtained on a material which is a square. And you can see in the lower image it is having a square shaped pyramidal indenter, pyramidal shape. So another thing that you have to keep in mind, it is also used in cast golding. Okay, see why I have included all these things is like some of the question I've seen is like which is being used for actually hardness test has been used for a dental gold alloy. So the answer will be Brinell test. And if Vickers test is also given that you have to answer both of this, Brinell test and Vickers test. That is why I have included the most important topics like this. So casting gold and the dental gold alloy, we use Vickers test. That is very important point that you have to keep in mind. Again, ask question. Noob test is a very suitable material for very thin plastics and metal or brittle. So all the three have been included here, and the force applied should not be more than 35 Newton. This is again the question which has been asked among the following which is not correct. So for that you have to know this point. And for noob test, three important things. It can be used in all the material, thin plastic sheets, metal sheets, brittle material, and the force should not exceed above 35 Newton. You can see in this image, it is having a pyramid shape, right? So let us go to the first question that we have discussed. See, what is the shape of the noob hardness test? Now we know it is always a pyramid or a rhomboid shaped. Okay, it is not a square shape, it is not an oval shape, it is not a rectangle shape. So please keep this important points in your mind. The various hardness test, the various shape of the indenters that is used, and what is the force that is used, whether it has been used in metals, plastics, or thin sheets, etc. Next important point to add on to hardness test is this two test. Shore and Barkle test is used for measuring hardness of. You'll be given four important options, so you have to answer on that. It might be like a metallic structure, a casting alloy, rubber, plastic. So the answer is like rubbers and plastics have been actually calculated or measured with the help of Shore and Barkle test. Please keep this point in mind. Next question. Which of the following atomic bond is characterized by physical forces? So we know that forces are of various type, primary forces and secondary forces. So the primary force, we know it is like the metallic force, covalent force, ionic force, etc. The secondary forces like the Van der Waals force, we've already studied that. Like, so the primary forces are those forces where there is electron exchange. So there is a proper reaction between the proper bonding between the atoms taking place in primary forces. But in the case of a secondary forces, there is no electron exchange taking place. But instead of that, there is only a physical force that is being involved. So we know that in this option, ionic is a primary force where electron exchange is seen. So that is not the answer. Second, Van der Waals force is there. Third, Van der Waals force is a secondary force which actually use the metallic, not the electron exchange, but it actually use the physical force. So the answer for this question is actually the Van der Waals force. So please keep in mind the secondary forces or the secondary like energy bonding like the Van der Waals force have a physical force, no electron exchanges. See. Next, based on wetting, how much should be the degree of contact angle for proper wetting to take place? So we know that for a surface to have the proper liquid to wet in that, it should have a contact angle of 0. So please keep this in mind. If the contact angle is 0, that means that there's proper wetting of the surface taking place. Okay, the answer is 0. Some important point that you have to keep in mind. The first is like, as I told, if the contact angle is 0, there is complete spreading or complete wetting of the surface taking place. See, if the contact angle is less than 90°, that means that it will have a good wetting. If it is equal to 90, it is having incomplete wetting. And if it is more than 180°, it is having non-wetting. So please keep in mind, 0 means complete wetting or complete spreading of the liquid is seen. While in the case of wetting angle or contact angle more than 180, that means it is not at all been wetted the surface. Some other important questions that has been discussed from wetting I've added in a very small box I've taken from this text. See, now what is the contact angle? Contact angle is actually the angle formed by the adhesive and the adherent is called as actually the contact angle. So if the contact angle is 0, as I told, there is complete wetting take place. If the contact angle is less than 90°, that means it results in the rise of actually the fluid. There will be increase in the rise of the fluid taking place. If the contact angle is less than 90°, what happens is like there is depression of the liquid taking place. And another question being asked is like, what is the contact angle for contact angle between saliva and acrylic denture base? It is 75°. Please keep this in mind. And what is the contact angle between glass and mercury? It is 135°. So this is actually based on on wetting. So wetting, you need to know what is the contact angle, what is the difference between various angles. So please keep in mind, zero complete wetting, 180 means it is non-wetting taking place. And this another question, these are all single question that has been actually asked. First question, again asked twice or thrice I have seen this question. What is the contact angle for saliva and contact angle between saliva and the acrylic denture base, that is 75 degrees. So please keep this important points in your mind, which is very important. Next question is the coefficient of thermal expansion of which of the following is more similar to that of the tooth? So what is coefficient of thermal expansion? Coefficient of thermal expansion means when we apply a very small amount of heat, like 1 degree centigrade, there is actually increase in the or there is actually transfer of energy through through that material taking place. So what is the coefficient of thermal expansion which is similar to that of the tooth? For this, we have to know the linear coefficient of thermal expansion of various material. First of all, talking about enamel and dentine. The enamel, which is the hardest structure in our body, is having a linear coefficient of thermal expansion of 11.4. Please keep this in mind. Dentine, it's 8.3. Now, we have to compare all the other material to the enamel and dentine. See, dentine is having 8.3. See the silicate cement and GIC, it is 10 and 11, which is very much similar to that of the enamel. It is always said the coefficient of thermal expansion of the teeth and the material which we place on the teeth, which should be almost equal. Why? What happens is like, we know that in our oral cavity, large amount of changes take place, right? Like we are being prone to heat, cold, etc. So what happens is like the material as well as the teeth expand based on the heat that is being applied on to our mouth. So see, if the coefficient of thermal expansion of enamel is 11.4, just think that if it is 11.4, enamel will rise a bit. So think about, see, it is amalgam which we have placed. It is 25. So it will rise so much. So what happens is like this amalgam will apply a pressure on the enamel, causing what cracks on enamel. That is why the linear coefficient of thermal expansion should be almost same. So comparing this table, please keep in mind enamel and dentine, it is like 11.4 and 8.3. The linear coefficient of thermal expansion of the material which is near to dentine is silicate cement. And next is type 2 GIC. Sometimes the question might be having only type 2 GIC. So give answer that. The first answer, if it is silicate is one option and another option is actually the type 2 GIC, you have to give silicate as actually the first option. So coming to the question part, the coefficient of thermal expansion of which of the following is more similar to the tooth? So the answer is actually silicate cement. If it has been actually GIC, like after silicate, the most common is actually GIC. Please keep this in mind. The values has also been like by hearted. This is very important. At least keep in mind the dentine, enamel, GIC, and the silicate cement that has to be kept in mind. So next is a question that is image based. Which of the following is marked as X in the stress strain curve shown in the color plate? So you can see the stress strain graph of a material in this image. So the option is like fracture, yield point, yield strength, and ultimate strength. So most of the people actually know this graph actually. We know that there's two regions. It is divided into two regions. Here it is called as the elastic area, and after that area it is called as the plastic area. Elastic area means whenever we give a pressure to a material, a stress is given on a material, but a strain is also developed within that material. But to a particular limit, the stress is directly proportional to strain. That is Hooke's law. It can come back to its normal shape and size. Like when we expand a rubber band, it can come back to its normal position, right? See, what happens once we actually expand the rubber band beyond a limit, it actually breaks. That is actually breaks in the ultimate thing. Like from elastic, they move to a plastic area where it comes back to its normal position, but not as similar as that of the same shape which it had. So So to keep in mind, what is the options given? Fracture, yield point, yield strength, ultimate strength. The answer is B, yield point. What is yield point? For understanding that, you have to keep, I have added one more image. Yield point is otherwise called as the elastic limit. Means the point at which in a material changes from the elastic to the plastic area. Understood? Please keep this in mind. Most of the people don't know this term. That is because we are often actually used to deal with only the elastic limit, the heading elastic limit. So the other name of elastic limit is actually yield point. Please keep in mind it is yield point. Okay. So the answer for this question is yield point. Next question. A fluid having constant viscosity that does not depend upon the strain rate is. So we know that there are various fluid types with various characteristics. So here it is given that it does not depend upon the strain rate. Means there is something proportional taking place. If stress is applied, strain is equal. It is not directly proportional to the strain. The question is like a fluid having constant viscosity that do not depend upon the strain rate. Means what? There is certain, a constant viscosity is there, but it is not depending on the strain. So there are various names being given like the plastic, pseudoplastic, viscoelastic, and Newtonian. So before going into the answer, I would like to give a small description about or an important point that you have to keep in mind when you answer this question. What is Newtonian uh, fluid? So it is actually an ideal fluid. That is because anything proportional is ideal, right? So Newtonian means a fluid which is ideal where the stress is directly proportional to strain. That is why the answer for this question is Newtonian. Why? There is directly proportional. It is not depending on either strain or the stress. Understood? That is why constant viscosity. The answer has been given constant. Something constant means there should be proportionality. So it is showing that there is proportionality between the stress and the strain. So the answer goes to Newtonian. So why not the others? What is pseudoplastic? Pseudoplastic means the viscosity decreases with increasing shear rate. So viscosity decreases means what? There is actually flow of the material taking place. So pseudoplastic means it is having actually a flow. Now what is a dilatant? Dilatant are actually liquid which are more rigid with increasing shear rate. That means that it is not having that of a flow. So please keep in mind, dilatant, even though the term seems like the liquid actually flow, it is not flowing. It is more rigid with increasing shear rate. Next is thixotropic. Thixotropic is a liquid which becomes less viscous and more fluid under pressure. That is a term you have to see. So don't see on whether it is viscous. Sometimes the question might be a liquid that is decreasing viscosity under pressure. We might not be actually seeing the term under pressure, right? So if it is under pressure, a term is seen like that, go answer thixotropic. So hope you understand all these four. Newtonian, think that term, it's Newton. So they are having proportionality, which is an ideal flow. Pseudoplastic means plastic means there will be flow, viscosity is decreased. Dilatant is just opposite. Dilatant means there is no flow, it is very much rigid. Thixotropic, think like thixo. It is like something thick, something pressure has been applied. Eh? Example for thixotropic has been given, dental prophylactic paste, plaster. Why I have added that is like some of the questions have been asked. Which of the following material? There it is actually which is thixotropic. So some of the options which has been given is like prophylactic paste, plasters, resin cement, some impression materials are thixotropic. Please keep this in mind. Very important question. Next question. Thermal diffusion through a material depend on thermal current. What is thermal diffusion? Actually, I've added a very small clipping from one of the text, which is very important text, Craig. See that? What is thermal? So actually, I have got a what a photo stat of that. I would like to give a definition from a standard textbooks itself. That is why I actually added that. It is not clear. I'll read it. Thermal conductivity. What is thermal conductivity? That was a question that is asked. So there is two important things. Thermal conductivity and we know linear coefficient of thermal expansion, which we have already studied. So thermal conductivity is actually thermophysical property, and it is actually a measure of the heat transfer through a conductive material. So it is actually it's a thermophysical property where what is the amount of heat that has been actually transferred through the conductive material, that is thermal conductivity. Okay, now what is thermal coefficient of thermal expansion? It is a quantity of heat in calorie per second that passes through 1 centimeter thick material. That's it. Some of the point that you keep in mind is like, see, materials with a high thermal conductivity is called as conductor. Material with low conduction is called as actually insulator. SI unit of coefficient of thermal expansion. Again, ask question. So that is watts per meter per degree Kelvin. So please keep in that is W per M per Kelvin. So that is a very important topic, the headings that you have to keep in mind. Okay, so higher the value, greater the ability of the to transmit it. So we know that coefficient of thermal expansion more will be the conduction of the heat taking place. So these are the terms that you have to keep in mind. And the question is like thermal diffusion through a material depend upon thermal conductivity and it is the thickness of the material that is being affected. Okay. Next question. The phenomenon by which a substance appear different under varying condition. So varying condition means we have seen some of the conditions where there is change in, so we might see a car that is actually seen under a light and we might feel like it is actually green color. Once it come out of that light, it is like black color. So that is actually called a substance appear different color or different texture based on various condition of various light. That is actually called as, so you have to properly read. Sometimes we might get confused and we might actually read the first like option like mesomerism itself as like metamerism and we'll give the option as first. So always read the question, always double check the spelling and because the spelling has been actually as you can see in this also, first and second, there is actually slight difference in the spelling actually. So mesomerism, it is not mesomerism. Metamerism is the phenomenon. Okay. Now we have to, it is not fluorescent, it is not a refractive index. So common question. So I would like to explain what is fluorescence. So the energy that a tooth absorbs converted into light with longer wavelength and become a light source. That is called as fluorescence. So I'm a body, I absorbed light and I actually gave a light out with longer wavelength. Just keep that in mind. Longer wavelength mean that is called as fluorescence. So another PGI June 2011 question is like, what is Benzold-Bragg effect? There is a change in the color or hue due to change in the brightness or intensity. That is specifically given. In the previous question, it was like varying condition. Please keep all these in mind. If there is varying condition, it is metamerism. And this is like change in the color and hue due to change in the brightness or the light intensity. That is actually called as the Benzold-Bragg effect. Next question. Munsell system is actually used for. So it is quantity of the color, quality of the color, quantity, quality, none. Again, very confusing question. Please keep it in mind. Read continuously because Munsell system actually uses hue chrome value. So we have seen the Munsell system, we have studied that. There they actually use the hue chrome and value. And the Munsell system actually see the quantity, not the quality. We have seen the quantity, right? It is not how much amount of hue, how much like saturation, everything. It is quantity, quantifying. They are giving number from 0 to 1, etc. So it is like the quantity, not the quality. So I've added some important point. One of the most commonly used method to define and measure color quantitatively is Munsell system. Color has been traditionally used by Munsell system. Yeah, as I told, hue value chrome has been actually used in the Munsell system. So another important question is like, which system is used for the quality? So for quality, it is Commission Internationale or CIE system. So please keep this in mind, very important from the color. So Munsell system, it actually gives the quantity, not the quality. Quality is given by the CIE system. Next question. Water of reaction needed to react completely with 100 gram of calcium sulfate hemihydrate to convert it into calcium sulfate dihydrate. So we know that we know that what we get is like calcium sulfate hemihydrate, that is half H2O, and we have to add water to that, where the water react with calcium sulfate hemihydrate to form calcium sulfate dihydrate. Like, so please keep in mind how much is the water required is like 18.6 ml. So I have to give some important point regarding this. The first is like, so 100 gram of plaster of Paris, as I told, it required about 18.6 ml of water is actually required. What does that mean? That means for a complete reaction to take place, there should be 18.6, at least 18.6 ml of water is required. Now there is something called as water of crystallization. So for that, more amount of water is actually required. For that, more amount of water is required. It is not 18.6. Just keep in mind, for 100 gram of plaster of Paris, we need 18.6 ml of water. But there is something called as water of crystallization, where there need more of water. See, you have to keep this box it in your mind. For type 1 and type 2 plaster, it is 45 ml of water that is required. For type 3, 30. You can memorize like 3, 30. For type 4, it is 20 ml. Again, very important question that has been asked. So see the calculation. For type 1, we know that 45 ml is required. So 45 minus 18.6 is the water which is required for what? It is the water required for actually the conversion. So remaining is 26.4. That is actually called as the wet strength. Wet strength or green strength is obtained when excess water than the required for hydration of hemihydrate is left in the specimen. So this is a very important calculation that you have to keep in mind. That is because there is a confusion being generated. Sometimes the question might be like, what is the wet strength of a type 1 gypsum product? So you might be get confused. So I know only 18.6. So just keep in mind 18.6, you keep in mind. That is the amount that is required for the conversion. One. Second, you have to keep this box in your mind. Then just subtract 18.6 and the residual of all these keys. So just think type 4. Now the question might be like, what is the wet strength for a type 4 gypsum product? So you know that it is 20 ml the total water minus 18.6. The remaining is actually the wet strength. So wet strength, another name is green strength. Please keep this in mind, and this calculation is also very important. Please keep this in mind. Next question. All of the following statement about the differences between self-polymerizing acrylic resin and heat resins are true except. So we know that heat cured resins are very common. We know that we used to cure the resins and we used to actually give heat for the proper polymerization. So there are a lot of acrylic resins like the self-polymerized acrylic resin where we don't give any energy. So think. Self-polymerization means, of course, the molecular weight will be very less, right? One. Second, the what happens is like once they set, there will be large amount of residual monomer that is seen. That is the advantage of heat cured resins, where we give an external source of heat, and the amount of residual monomer will be less in the case of a heat cured material. So that is a very important point that you have to keep in mind. And we know heat cured is less porous when compared. Heat cured is which we do in our clinical practice. So keep that in mind. Why we do heat cured? That is because it makes that denture less porous one. It is having less of residual monomer too. And third, they are having a larger molecular weight. Okay. So see the options, and which will be having more strength. Heat cured. That is why we actually opt heat cured acrylic. Right. So go for the option. The former, that is, former means self-polymerized acrylic resin, have a low molecular weight. Second, the former have a high residual molecular content. Third, The former are more porous. Fourth, the former have a great transfer strength. So the answer is actually 4. It is wrong. The former means self-polymerized acrylic resin is not having that much of a transfer strength compared to that of the heat-cured resin. So that is the difference between self-cured acrylic resin and heat-cured acrylic resin. Next question. While working with dental material, the C factor is associated with. So options are like condensation force, tensile strength, polymerization shrinkage, carving of amalgam. So C factor is polymerization shrinkage. What do you mean by polymerization shrinkage? It is actually defined as the actual length by the total length. So we think that we actually give 100% of composite to a cavity and we cure that. What happens? What happens is like there is polymerization taking place and there will be curing of the or polymerization reaction taking place between the monomer and there will be decrease in the space between the tooth structure because of the decreased quantity of the composite giving to very small space in between the composite and the tooth structure. That is actually called as polymerization shrinkage. And various problems with polymerization shrinkage include like there is micro leakage taking place, secondary care is taking place. So all those are a common factor or problems that has been actually associated with composites. Okay. So the answer is polymerization shrinkage. So some important term related to this that is commonly been asked is like first is the degree of conversion. What is the degree of conversion? Degree of conversion means the percentage of carbon-carbon double bond that has been converted to a single bond to form a polymeric resin. This is called as degree of conversion. Now, what is configuration factor? That is C factor that we have already discussed, which is responsible for polymerization shrinkage. Please keep this formula in your mind. Configuration factor is actually the bonded wall to that of the unbonded wall. Bonded wall means how many surfaces are actually not bonded. Okay, for class 1 it is 5, class 2 it is 2, class 3 it is 1, class 4 it is 0.5 and class 5 it's 0.2. Please you can correlate this and study, it's very easy. First you remember it's 5, 1, 2, 1 and this gives 0.5 like 5, 2. 5, 2, 1. That is the thing how you can actually memorize. Okay, hope you understood this very important point. Next is based a question that is actually from the physical property. The first is the fourth state of matter is. The fourth state of matter is actually colloid. So please keep that in mind. The fourth state of matter is colloid. So impression material, before going into the question, I have given some of the synonyms that you can memorize while writing this question because lot of questions has been asked from just this box. See, mode of setting, there are two mode of setting. First is the setting by chemical reaction. Second is the setting by temperature. So we know that anything that's set by chemical reaction is actually irreversible. Okay, and it is also called as or thermoset in nature, right? So the mode of setting, they are of two type, rigid and elastic type is there, right? So mode of setting means how they set. So through the chemical reaction, they have two type, that is the rigid type and the elastic type. So I've given a code RIPE, right? RIPE means R for rigid, I for impression blasters, RIP means impression blaster, and E for eugenol. Please keep this in mind. That is actually the rigid type. What about elastic type? Mode of setting, that is actually chemical reaction set by chemical reaction, but it is having an elastic nature. Okay. Answer for that is alginate, right? And polysulfide, polyester. You can memorize it as APES, apes. Ripe banana has been eaten by apes, right? Just think like that. Apes, A for alginate hydrochloride, P for polysulfide, P for, again, PE for ether, and S for silicons, right? Next, which has been set by the temperature. We know we give temperature through hot water, etc. Rigid is like compound wax, and elastic is like agar hydrochloride. So please keep this important slide in your memory. This is very important because most of the question can be answered through this slide. Alginates are. So the question, alginates are. So we have already given alginate hydrochloride, which is elastic. So the answer is like hydrochloride. Inelastic impression material is. So we can again go to the inelastic type or non-elastic type. It consists of impression plaster, zinc oxide, eugenol, and compound. This thing. So the impression compound is actually the inelastic impression material that is actually given. And another important question, which of the following impression material is rigid? So the question is like zinc oxide eugenol, reversible hydrochloride, alginate, polysulfide rubber. So the answer for this question is like the zinc oxide eugenol. That is the impression material that actually becomes rigid. Next, coming to the question, soft or slow start polymerization is seen in. Okay, so as I told in the previous slide, there is large amount of very sorry for the disruption. Slow or soft start polymerization in CNN. So as I've told early, so we know that there is something called as the polymerization shrinkage. So in order to actually reduce the polymerization shrinkage, what I have given is like we have brought up a large amount of methods like the resin. There is modification in the resin one. Second, there is actually modification in the curing techniques too. Third, there is actually the newer techniques of actually curing. There are a lot of modifications that has been actually brought where the commonly seen problem like polymerization shrinkage can be actually reduced. One such mechanism is actually the slow or soft start polymerization. So we know that normally we give the light cure for this much second as such. But what happens is like there is a chance of large amount of polymerization shrinkage. So one of the newer method that is a slow start polymerization, what is it? It is actually using a curing lamp with a lower intensity initially, and we'll be actually slowly increasing the intensity of the light that has been used. So curing light that is designed for this technique produce low intensity light of actually 400 milliwatt per centimeter square. Very important question again asked. What is the concentration or what is the quality of light that is used for a soft start curing technique? That is 400 milliwatt per centimeter square. That will be given for 10 seconds, followed by 800 milliwatt per centimeter square for the remaining session. So please keep in mind. Another is actually pulse delay. So that are the various types of ramped curing. So these are the various types of curing techniques. So we know that the layering techniques are there, where studies have shown that 2 mm thickness of composite is only to be kept in the cavity so that proper curing of the composite actually take place. So keep that also in mind. What is the amount of composite that can be actually placed in the cavity to reduce polymerization shrinkage is actually 2 mm. Please keep that also in mind. Very important question. Next question. In heat cure denture-based acrylic resin, the monomer is. So again, I told we have already discussed it about the heat cure and also the self-cure dental acrylic resin. So it is methyl acrylate. So heat cure denture always have methyl acrylate. So something I have like to discuss is like, we know that the monomer have methyl acrylate is there. So it is actually unpolymerized. So we need a initiator which will start the polymerization reaction. So the initiators are various substances that will actually start the reaction. Okay. Normally, which we use is actually the benzyl peroxide. That you have to keep in mind. Benzyl peroxide is actually the initiator, and it has been activated by 2 methods: heat as well as the chemical method is there. So this is very important. Methyl acrylate is actually that you have to keep in mind. Methyl acrylate is actually the monomer that is seen in heat cured denture base, and it is there is a initiator that is benzyl peroxide. It's been activated by heat as well as actually the chemical reaction. Now, normally it is actually exothermic reaction. These are the points that you have to keep in mind. Next, we know that there are various other types, like the cold cure is there, self-curing resins are there, auto polymerization resins. All these, it's not the benzyl peroxide. There, the initiator is N dimethyl P12D. Please keep this very important point. So some important point that you have to keep in mind again from heat cure denture. So we know the composition already studied. It is methyl methacrylate, that is actually the most common. It is having a shelf life of 2 years. You can see the major com component is polymethyl methacrylate. Very important. Another asked question, what is the initiator? All the points in this is each question. Please keep that in mind. See, which is the most common? Polymethyl methacrylate. Which is the initiator? Benzyl peroxide. Which is actually the opacifier used? It is actually titanium oxide. Which is the plasticizer that is used? So you remember as phthalate, PP. So it is dibutyl phthalate. So what are the filler particles? Filler particles will be always like some glass materials like silica, zirconia, aluminum oxide, etc. Okay. So all the questions here is very important. Liquid is again methyl methacrylate. Plasticizer is there. All these plasticizer is like PP phthalate. Okay. And another important slide is the last one, hydroquinone. What is the use of hydroquinone? They prevent premature polymerization. What is premature polymerization? As I told, there should be a heat which activate the monomer to cause that polymerization, right? So what happens if some heat actually occurs before we need that? To prevent that, actually, hydroquinones are used. So hydroquinones are those which actually prevent the premature polymerization. So please keep this point in mind. It's very important. Self-cure, as I told, benzyl peroxide is for heat cure. Self-cure, it is dimethyl P12D, okay, which is a tertiary amine. Sometimes it might not be like dimethyl P12D. The options will be like tertiary amine. So please, benzyl is always alone. It is not having any other name. But dimethyl P12D is having tertiary amine. See the question, use of dimethyl P12D. So we know that what is the use of it is indicated for what? It is indicated for chemical polymerization. Next is hydroquinone is added to methyl acrylate. We have already studied that is used to prevent the polymerization during storage. That is why I told each and every point in that slide is very important. So some important point from composite, it is bifunctional. Please keep that in mind because it can actually adhere both to the tooth structure as well as actually composite. This is all you know, which is a resin material, filler material, coupling agent. I would like to add this important point. Filler particles, we know it actually strengthen the material, and barium, yttrium and zirconium are the popular fillers which produce radio opacity. So the question is like, which of the following material give radio opacity to composite? This is very important. BYZ, barium, yttrium and zirconium. Please keep this in mind, very important. I've just added, not the question, I've just added the points. Coupling agent, we know that coupling agent is like the organosilanes, and the silanol group adhere to the inorganic substance on one side, and this and the methacrylate group on one side joined with the resin group through copolymerization. As I've already discussed, some of the important point, chemical activator, we know it is actually benzyl peroxide on one side, and the paste B is having tertiary amine. So you can memorize like A, B, C. A for amine, B for benzyl peroxide. C, this is, we are talking about composite. The other, we were talking about the acrylic. Don't get confused. Okay. So here it is A, B, C. C is the last. Chemically activated, we have amines and the benzyl peroxide. Light activated, it's benzoin methyl ether. It is actually the initiator. Right. So we actually use visible light and camphoraquinones in present. That is another question. What is the amount of camphoraquinones that is present? It is actually 0.12 percentage of weight. This is also another question. What injury does the UV light system in composite causes? It is retinal damage. Another question. What is the depth of cure in a UV light? It is 1.5. Next question. What is the depth of cure for a visible light? It is 2 mm. So all the question in this is actually questions, or which of the following is not like right. UV light keep in mind, which we use is like visible light. That is 400 to 480 nanometer. UV light is less than that, 360 to 400 nanometer. Understood? Next question. Water-resistant sealant among the following. So this is another question. It is cyanoacrylate. Actually, cyanoacrylate is actually most water-resistant. So they has to be used very carefully when the reaction takes place. It has to be used properly because there is chance of actually contamination. So water-resistant sealant is always cyanoacrylate. Next question. Minimum exposure time for composite should be. So this is very important. So sometimes we might actually confuse. We cure the light for 10 seconds or 15 seconds. No, that is not the answer. They are saying we can actually simply cure it slightly. To what point we can cure such that it sets completely? So it is 40 seconds. Never get confused. What is the minimum exposure? How much exposure a composite can attain to maximum before they actually enter into a solid phase? That is 40 seconds, not like the 50 seconds curing time which we take. Please don't keep that in mind. This is the minimum exposure time for composite. It should be actually 40 seconds. Next, the type of spatula used for composites. So we know that normally the spatula which we use is plastic spatula. Please keep that in mind. That is because the other spatulas like stainless steel spatula, iron spatula, etc. Actually, what they does is like they actually affect the polymerization shrinkage. That is why we actually avoid the polymerization. That is why we actually avoid the various other materials like the steel, the iron material, etc. Because they actually inhibit the polymerization of the composites. Next question. Which of the following emit light of single wavelength? This is a very important question again. Uh, like laser, we know that various lasers have been actually used for the curing. And argon laser is the only laser which actually works at a 490 nanometer, which is actually emit only a single wavelength. The LED lamp and QED lamp, quartz and tungsten, etc. actually have a bulb, incandescent bulb inside that, and they actually produce the light. But carbon dioxide laser and argon lasers are the laser where we give a nanometer of actually the wavelength of light. And among that, argon laser is the only laser that is having or that will be emitting a single wavelength of light. Very important. Next question. For aesthetic area, which high luster is required? Where a high luster is required, which is indicated? Glass ionomer restoration, hybrid resin composite, microfield composite, macrofield composite. Just to know which composite is called as a polishable composite. It is a microfield composite. So that is another question that has been seen, which is a polishable composite. It is a microfield composite that has been used. So please keep this in mind. So whenever polishing is extremely good for microfield, that is why in aesthetic areas and where high luster is required, we actually use a microfield composite. Another important question, which is called as a universal bonding system. Just memorize like for bonding the amalgam to the tooth structure, we use 4-meta, right? That is because 4-meta is having a bifunctional character, or it is like a primer which can actually adhere both to the enamel as well as dentine or the resin matrix. That is why it is called as a universal bonding agent, because it can adhere to enamel, it can adhere to dentine, it can adhere to amalgam, everything. That is why it is called as actually the universal bonding system, meta. Some important thing that you have to memorize with meta is like, what is the bond strength? Sometimes the question has been asked is like, which combination of meta have large bond strength? See these options. Sometimes the option might be like dentine, enamel, or some other options. Among dentine and enamel, the 4-meta show maximum bond strength to the dentine. So please keep that in mind. It actually show maximum bond strength to dentine. Then only it show actually bond strength to enamel. Okay. Followed by the acid etched enamel. So please keep that in mind. Acid etched enamel in its combination with bis GMA. Please keep that in mind. This slide is very important. Next question. Resin penetrates collagen network that do not penetrate completely a small gap between the mineralized layer of dentine and collagen resin hybrid layer is called as nano leakage, right? We know, as I told earlier, there is polymerization shrinkage taking place in composite. That is because properly the resin might not actually penetrate into the hybrid layer, and there might be small spaces called as a nano leakage. So the question is like, what is the amount of nano leakage that is seen? So option is like more than 0.1, less than 0.1, more than 0.2, less than 0. The answer for this is actually less than 0.1. Actually, this is a very vague answer or options that is given. So if such a option is given, you just write it is less than 0.1. Actually, from textbooks, it has changed, saying that the size of these porosity is 20 to 50 nanometer. Okay, so because there is no proper like adherence of the composite materials into the resin matrix and the hybrid layers, there is actually chance of large amount of porosity where there is nano leakage taking place. If a question option is like 0.1, 0.2, the option may be less than 0.1. If it is based on actually the nanometers, it is 20 to 50 nanometer. So this was all the very important questions and recently asked questions over the last 10 years. I've not included all. I've included only some questions which we are actually not much we discussed during our last previous classes. So any doubts, please come and we'll have a discussion. So come contact the Idento team. We'll be there for you at all time. Have a nice day. Please do like see this video again and know the important points and read it continuously. Thank you.